everyone, so today we're going to be on day 2 of solving systems of equations by multiplication, where we have to multiply both equations by a number to create a set of additive inverses. So let's take a look. Solving systems of equations by multiplying both equations. Solve the following system of equations. We have 3x minus 2y equals 2 and 5x minus 5y equals 10. We don't have additive inverses, we don't have identical terms, and we don't have an equation in the form of x equals or y equals. So we know that we're going to have to create a set of additive inverses here. So to start that, I'm going to list the LCM for x. For my x variable, for the coefficients of x, I should say. And the LCM of 3 and 5 is 15. You can list out your multiples if you want. I'm not going to do that here. I'm using my mental math. Okay, and then the LCM for the y. Oh, let me be specific here. I'm going to just put a little x right there so we know that that's for the x values. And then for the y, just to be as specific as possible. So the LCM of y for 2 and 5 is 10. Notice how I'm not really paying attention to the signs. I'm really just paying attention to the numbers for this part. And then we're going to talk about the signs in a minute. So none of my equations contain either of these LCMs. There's no 15 here and there's no 10 here. So it comes down to just a matter of choosing which one you want to focus on. Last time I focused on x, so today I'm going to focus on y. I'm going to change both of my values into a set of additive inverses containing positive 10 and negative 10. Okay, so I'm going to forget about the 15 for now. Also, 10 is just a smaller number, so I'd rather work with smaller numbers. But you can choose whichever one you want as long as you follow the right steps. So we're going to be multiplying both of these equations by some number, and it's going to be two different numbers, to create that set of additive inverses, negative 10 and 10. Now pay attention here, because both of these numbers are negative. And remember, to have additive inverses, one has to be positive and one has to be negative. So that means we're going to be multiplying one of these equations by a negative number to make it a positive, because a negative times a negative is a positive. Okay? One of them we're going to keep negative, and then one of them we're going to change to be a positive. It does not matter which one you choose is going to stay positive or negative, as long as you only do it to one equation, because we need those opposite signs. So let's look at this first equation. This negative 2y, I want to make this into a negative 10y. So what number times negative 2 would give me negative 10? So what you can do is take that LCM of 10, divide it by 2 in your head. 10 divided by 2 is 5. So we're going to be multiplying by 5. And I'm going to keep that negative. So I'm going to multiply everything by 5. We get 15x minus 10y equals 2. And I'm going to just kind of square this off in its own little thing, because that is just part of that. Okay. Now the second equation. I want to change this negative 5 into a positive 10. Remember, additive inverses, we need one negative, one positive. So I'm going to multiply this bottom equation. 10 divided by 5 is 2. So I'm going to multiply by negative 2. And watch what happens here. Negative 2 times 5 gives us negative 10x here. Negative 2 times a negative 5y gives us a positive 10y. And then negative 2 times 10 is negative 20. So notice, when I multiplied the negative and the negative, that gave me a positive, which now created those additive inverses of negative 10y and positive 10y. From there, we should know how to do this. We're going to add these together. My additive inverses are going to cancel out. 5x plus 10x, 15x plus a negative 10x gives us 5x. Oh, I made a mistake. Hopefully you caught that. 5 times 2 gives me 10. So the mistake that I made is one that a lot of people make. So it's good to check your answers as you go. So that was my fault. I'm sorry. Okay, so now we have 10 plus negative 20, and that gives us negative 10. Right, divide by 5 here, and we get x is equal to -2. So be very careful. Do not make the same mistake that I made, the one that I warned everybody about. Make sure you distribute to everything. I'm going to take our x value and I'm going to plug it into one of our original equations to solve for y. Remember, one of the original equations. Do not choose one of these. Choose one of these. I'm going to choose the first one. It has smaller numbers. I like smaller numbers. And wherever I see an x, I'm going to substitute a -2 in. So I'm going to have 3. Instead of x, it's going to be 3 times -2 minus 2y equals 2. Multiply here, we get -6 minus 2y equals 2. Add your 6 to both sides. That cancels. You get -2y equals 8. Divide by -2, and we get y equals -4. Remember, don't forget to write your answer as a coordinate, -2, -4. So if we were to graph these two lines, this is where they would intersect at that point. Okay? So in this situation, this was a little different because we had terms that had the same sign. And if they have the same sign, then you know you're going to have to multiply by a negative number somewhere. We could have multiplied by a -5 up here, but then this would have had to have been a +2. So you have to change one of the signs to create those additive inverses. Solve as you normally would. Make sure to look out for mistakes like I did. And that's it.